Hello, everyone, and welcome along to this month's AMETEK Solidstate Controls webinar. Happy St. Patrick's Day to all those who celebrate St. Patrick's Day. And good morning, good afternoon, or good evening, obviously dependent on where you are in the world. As always, if you can please post in the chat bar that you can hear us okay, that would be appreciated. Wouldn't be much fun if you just had to watch a presentation without being able to hear us. So my name is Craig Williams. I'm the Senior Technical Manager based out of the Stafford office in Houston, Texas, as you can tell from my wonderful Texas accent. I've been working with AMETEK Solidstate Controls for, this is my 4th year, and I've been in the industrial UPS business for over 20 years now. So goodness me. And joining me on today's webinar is Rob George. He is our software architect in our R&D department in the Columbus manufacturing facility, our head office up in Ohio. And today we are going to discuss the AMETEK lithium ion battery based UPS solution. So hopefully that is what everybody was expecting when they joined us on our webinar today. I'm going to give it a few more moments for everybody to join, and thank you everybody for letting us know that you can hear us. I'll just go over the platform that we're using. The platform that we use is called Webinarjam. It basically has to process what I'm doing live into Android-based systems, Apple iOS systems, and Windows-based systems. And to do that is actually quite a complex thing. So it takes about 15 seconds for it to process. So when I say something, you're actually not going to hear it until about 15 seconds after I say it live. So when I see a question pop up in the chat bar, it's going to be around about 15 to 20 seconds behind where we are in the presentation. So please do ask lots of questions if you have any questions. We tend to wait until the end of the presentation to then start going through all of the questions and answer them. Because it does interrupt the flow of the presentation if we keep on answering questions as we go through. But if there is something that's very pertinent and we see it, then we may try to answer it at the time. Webinarjam does have what's called a panic button. So we've never had to use it before, touch wood. But what it means is if something happens with the webinar, if we lose connection, if something goes awry, then I can press the panic button, and what it does is it basically closes this room. It will open a new webinar room, and we will take over from where we left off. So it should work well. We have tested it, and it does work, but we've never had to use it live. Also, we've had some people who have had audio issues on their end. Usually it's always down to either local internet connection or local issues. So I think it either gives you the option to refresh the page, or you can just use your browser and refresh, and it should fix your issues, hopefully. Okay, so I think that's all we have to discuss about Webinarjam and how the webinar is going to go. The webinar should last around about 45 minutes, and it will obviously depend on how much we speak and how many questions are asked. We try to keep it under an hour, if at all possible. So, without further ado, today we're going to go through the AMETEK Industrial UPS product line. Then we're going to discuss the lithium-ion battery advantages, the interfacing that the UPS does with the lithium-ion batteries, the charging methods, and also the monitoring and communication. Okay. So just give you an overview of AMETEK itself as a company. We have annual sales of $5 billion globally. We are a global manufacturer of high-tech technology solutions, and there are basically 100 companies below the AMETEK umbrella specializing in following markets: energy, aerospace and defense, power, research, medical, and industrial. And they're all kind of separate companies. Like for ourselves, Solidstate Controls, although we come underneath the global umbrella of AMETEK, all of the companies within AMETEK are treated like separate companies, and we do our own thing under that umbrella. So I hope that made a little bit of sense. And the AMETEK SCI UPS product family, the key features: we do UPSs that range in size from 5 to 225 kVA UPSs, single phase and three phase. We have an LCD touchscreen user interface panel, what we call our MIMIC panel. We have system diagnostics, which include a data logger. So we log all of the alarms and data within our system. We have digital signal processors and a USB communications interface. And the options that you can get: we can do parallel redundant configuration. We're very proud that we do nuclear grade UPS systems, and that's really good for our customer base, because whatever UPSs we manufacture, basically we have to guarantee support for 20 to 30 years. So because they are nuclear grade, and that's part of getting nuclear conformance. So you know that our systems will be supported for a very, very long time. And we have a wide variety of configurable alarms, indicators, and meters that we can customize to your solution. Okay. And the custom one of the best-selling custom options that we do is the Slimline UPS. Obviously, if you have space requirements and you need to fit a UPS into a small area, we can do a single-phase DPP in a reduced footprint cabinet. So it's 610 by 700 millimeters, up to 20 kVA with top cable entry. So you can see on the picture there on the left is our Slimline DPP, and on the right is our normal size DPP. So it really does help if you're trying to fit a UPS into a tight space. So what I will do now is hand over to Robbie and let him introduce himself and take over from here.
Hi, thank you everybody for joining. My name is Rob George. I am the software architect in the R&D department at Solidstate Controls. I have been at Solidstate Controls for almost 13 years now. Started in IT and then moved to R&D after a few years. So I'm going to talk about how our DPP product line of UPSs can utilize a lithium-ion battery as the backup solution. Right now, at launch, we only are fully integrated with one lithium-ion battery. That is the SAFT Flexion line of lithium-ion batteries. But we are open to utilizing other batteries in the future, if need be. The advantage of a lithium-ion battery compared to lead acid and NiCad is that one advantage is that the footprint is much smaller than those two. You can see in this image that it's about 20% of the size of a lead acid battery. The installed volume is also much lower with lithium. You can see here the lithium is the yellowish brown box there compared to lead acid and NiCad. And the last advantage as far as size goes is that the mass of the lithium-ion batteries is much, much less than both NiCad and lead acid. So these are the major lithium-ion chemistries in the market. There are 4 of them. We have lithium iron phosphate, the LFP. We have NMC, the lithium nickel manganese cobalt oxide. NCA, which is lithium nickel cobalt aluminum oxide. And LMO, which is lithium manganese oxide. The batteries that SAFT uses are the LFP kind, the lithium iron phosphate. The These kind of batteries are typically used in home and grid storage options. And SAFT and AMETEK both chose this battery because of its better safety record and power density compared to the other chemistries. The other chemistries are just the uses for them. The NMC chemistry is used in smartphones and the Nissan Leaf. The NCA chemistry is used in Teslas and other smartphones. And the LMO is used in medical devices and power tools. So this is what makes up the SAFT lithium-ion battery. We have a cabinet here, is shown here. You can have multiple cabinets in parallel to make a larger battery with a larger capacity. But this one cabinet has it has 9 battery modules. You can also have a version with 5 battery modules for a 120 volt DC bus. What's shown is for a 240 volt DC bus. Next, we have the BMM, which stands for Battery Management Module. Inside this module is a circuit breaker, power contactor, and a circuit board that collects measurements for all the modules inside the cabinet. The BMM prevents short circuits and overcurrents. It also has overheating protection and overcharge protection. And it also has charge protection after an over discharge. So for lithium-ion batteries, or the LFP type, if you discharge the battery to 0%, it is not safe to ever recharge it and use again. So this BMM prevents that from ever happening. And then the last thing in the cabinet is an IntelliConnect. This is what the UPS connects to. It is a contactor in parallel with a diode. So this battery was designed so that you don't have to have any communication with the UPS to use this lithium battery. In our application, we do communicate with it, so this isn't necessarily required for us, but the IntelliConnect, if the contactor opens to prevent discharging or to prevent charging once the float voltage has been met. So if this contactor is open, you shouldn't be able to discharge the battery. But since there is a diode in parallel with it, discharging is always available to the UPS. So some of the benefits that SAFT lists for this Flexion lithium-ion battery is that it is greater than 8 times lighter than the installed weight of the lead-acid batteries, and it has a 4 times smaller footprint. The battery is more efficient than lead-acid and NiCad with 95% round-trip efficiency. You could charge the LFP lithium-ion batteries much faster than lead-acid or NiCad, up to 5 times faster, depending on the load on your UPS. The Flexion battery is rated for over 3,500 cycles to 80% depth of discharge, and has a 20-year lifespan at room temperature. And since it's a modular system, you can replace a single battery module if it fails, and the BMM has integrated cell balancing and supervision. The BMM also provides state of charge, state of health, alarms, voltages, currents, and other things too. There's a front panel on the battery, and in our case, these values are transmitted over to the UPS, so you can see them on the HMI for the UPS. Lithium-ion batteries have a lower environmental impact than the lead-acid batteries, and they are able to have optimized performance for certain applications. So this is the the diagram of our UPSs. We have our UPSs are online UPSs that have an integrated charger and inverter and a static switch. Those are the three main parts of our UPSs. The charger rectifies the incoming AC voltage to DC, and then the battery connects to this DC bus, which then feeds the inverter to convert the DC back to AC. And then we have a static switch to switch between the bypass source for the load and the UPS source. So this is we have two different rectifier designs. The top pictures are for a 6-pulse rectifier. You can see in the waveforms that there's a more ripple in this configuration than there would be with a 12-pulse rectifier, which is below. So when we connect to the lithium-ion battery, this is how the data path goes. So in the center left, we have our HMI for our UPS. That connects to the battery directly via Modbus TCP, and the HMI on the UPS pulls data from the battery at certain intervals. The HMI also connects to our charger controller inside the UPS, and so the values that are acquired from the lithium-ion battery are then forwarded onto the charger. So the charger can regulate to the voltage and current that the battery is requesting. So we never are going to go over the maximum voltage or current that the battery can handle. And the SAFT batteries, the maximum current and voltage vary depending on the state of charge of the battery, the temperature, and the state of health. And that's all calculated by the BMM on the lithium-ion battery. The UPS HMI is also capable of communicating with other outside sources. We have an application called SCI Link that connects via USB to the UPS, where you can download data logs and maybe change some alarm set points. We also have Modbus RTU and Modbus TCP available for connecting the UPS to the SCADA system for a particular client. The Modbus also forwards the data collected from the battery through our UPS to the SCADA system. There's also a web app or a website that you can visit on the HMI. And then finally, we have some Form C relay contacts that can be configured for certain alarms. When using a lithium-ion battery with our UPS, we have two different charging methods that we can use. First, we have the fast charging method. This charging method will give the maximum current possible to the battery to recharge it quickly, up to 5 times faster than standard lead acid or NiCad batteries. This is convenient if the UPS is not continually operating at full load. If it's at full load, the charger has less current available to use to recharge the battery, because it has to supply the load on the inverter as well. I'm going to talk about two acronyms here. There's called the maximum recharge current is called the IMR, and the maximum recharge voltage is called the VMR. The BMS on the battery decides what these values are and forwards them to the UPS. If you're using the fast method, the charger will supply as much current as it has available up to the IMR value. There is no battery current limit in this case, because the battery current limit is now replaced with the IMR, which is set by the battery. And if communication between the UPS and the battery is lost, the UPS will revert to the conventional method of charging that I'm going to talk about now. So the conventional method is it's very similar to lead acid that we use for currently. The battery voltage is in float, and the user can set what the float voltage, what they want the float voltage to be. But if the user sets the float voltage to be higher than the maximum recharge voltage specified by the battery, then the battery will go to the VMR and not, or the charger will go to the VMR voltage and not to the user's requested voltage. In the conventional mode, the battery current limit is used and can be set by the user. Once again, unless the IMR required by the battery is lower than the battery current limit that the user sets, we don't want to exceed the IMR because it will trip the breaker on the battery itself. This conventional mode is easier to understand for legacy system, or for the way the market is right now, but it does not take advantage of the faster recharge times of a lithium-ion battery. I'm going to talk more about the HMI of the UPS. These are the same things we talked about earlier: have Modbus RTU communication, web communication, and communicates with SCI link. So the DPP PWM UPS has the front touchscreen. This is where you can change or set your static switch position, view alarms, view data logs, view system measurements, and everything. You can also adjust set points for alarms or float voltage if you're using the conventional method. It'll view the system configuration, so how much power is available by the UPS or from the UPS. You can connect our Windows application SCI link to it to download data logs or reports. And the display is completely independent of the charger and the rectifier systems. The display can completely fail, and your load will still be backed up by the UPS. So we have 66 standard alarms that are in all DPP systems and an additional 74 optional alarms. All standard and optional alarms are logged when they activate, and they are displayed on the front screen. We also have the ability to accommodate up to 10 additional LED indicators on the front panel that can be mapped to certain alarms. And the same thing goes for 13 optional Form C contacts that can be mapped to alarms specified by the user. So these are some screenshots from our SCI link software. It uses a USB connection directly to the front of the UPS. And you can access system logs, parameters, and configurations. It allows for configuration in the field by our FSEs, and it also allows for calibration in the field. The communications package that we offer a web server, so you can view the status of the UPS from any website that's connected to the network, or any web browser connected to your network. We have Modbus TCP for reading voltages and currents, and Modbus RTU, which is the same as TCP with just a different connection method. Modbus TCP uses Ethernet, and Modbus RTU uses an RS-485 serial communication. I want to say all of our communications with the outside world are one-way communication only, except for SCI link, which you have to be physically next to the UPS. Anything that could happen remotely will not allow any settings to be changed. remotely. We also have an option for an SNMP communication. The graphical user interface GUI for the website has animated dials, and so you can see voltages, currents, that they're in the green or red if they go too low or too high, and you can also see the alarms. You can download data logs in additional formats compared to SCI Link. We can also, in SCI Link, we just have text files, but you can also download as a CSV. And you can do simplified data logs that just shows the alarm activated, or what alarm activated and at what time. Or you can show a extended version that shows what alarm activated at one time, and it also shows all the voltages and currents of the system at that time. We also have the ability to monitor all the readings and values that are available on the HMI if you're in front of the UPS remotely. And it's integrated into the display board, but it uses a separate module to isolate any external communications from our UPS. So say somebody tries to hack into the web interface. The web interface will stop working, but the UPS will go on as normal, except that you will get an alarm that says you've lost communication with the Ethernet. So these are the new screens, HMI screens, that we have for lithium-ion batteries. The UPS obtains these values from the battery using Modbus TCP. The information of the whole battery string is retrieved once a second by the UPS, but you can have multiple cabinets in a string. So those values from each cabinet are pulled every 7 seconds. You can see the alarms of the whole battery, all the cabinets. They're all combined into one alarm by the battery itself, or one interface by the battery itself. So you can see alarms for each cabinet or for the whole battery. And all the data that's available on the UPS display is also available on the web server, Modbus RTU, and Modbus TCP. As I said, you can retrieve data from each battery string every 7 seconds. Or a string is each cabinet. The status of each BMM is accessible via the USB display, web server, Modbus RTU, and Modbus TCP. Here are some screenshots of the battery status, the battery voltages, currents, and you can see if there are any active alarms. The bottom half of the picture on the right, everything is in green right now in this screenshot, but if an alarm activates, it'll turn red. We've added 4 new alarms that are standard for lithium-ion batteries. We have a battery fault alarm, this alarm is a UPS alarm that can be mapped to a Form C contact or an LED on the front of this UPS, and it will activate anytime one of the alarms in the BMS alarms activates. So it acts as a common alarm. If the battery fault alarm activates, it'll also activate the common alarm on the UPS. We have an alarm for battery temperature high. This will activate if the any battery cell temperature exceeds a temperature defined by the client, and this temperature can be adjusted via the screen, the UPS HMI or the SCI Link application. We have a low state of charge. This will activate when the state of charge of the battery goes below a certain threshold set by the client. This will happen before the low state of charge alarm should act, depending on how it's configured, should activate before the low DC disconnect of the battery, of the UPS activates. So this is it's like a first level warning. And then we also have a BMS loss of communications alarm that will activate when the UPS is not communicated with the battery for 30 seconds or longer. It also will activate if the data sent to the charger inside the UPS is not correct. So if the charger has a problem with any of the data, we will get an alarm. For being here, do you have any questions? I see there are some in the chat.
Okay.
So the first question, go ahead.
Yeah, I was going to say, so the first question is from Mark. Does a BMM or battery management system come with data logging? If you want to answer that, Rob.
Yes, the battery does have data logging on it. The UPS cannot require that data from the battery, so we cannot see the data log on the HMI or via the web page. But yes, the battery itself on its screen has data logging capabilities, and it is standard or enabled always.
Okay. The next question we have is, can lead acid batteries be replaced with lithium ion batteries directly, assuming the DC bus voltage will be comparable?
Okay. Yes, theoretically. There may be some retrofitting that's required, such as a new display board and updated charger and inverter control boards. But yes, we can do that.
Yep, and in answer to that question as well, I know this is basically more of a SAF-based, the interaction between our UPS and the SAFT Flexion battery, but the lithium-ion battery manufacturers are trying to design batteries that can be attached to UPSs without the interaction between the UPS and the battery itself. In doing that, you lose a lot of the benefits that Rob has already said, which is the fast recharge, the fact that you will have to connect two separate Modbus communication signals, one to the UPS and one to the battery, to get alarms and details from it. So it can be done, but we also found out recently, because we had a situation where we did have one of our DPPs, they replaced their lead acid battery with a lithium ion battery, and we needed one of our field service guys to go out to the field and change some parameters, because even though the DC bus voltage is similar, it's not the same. So the high voltage set points, the low voltage set points, the low voltage disconnect, all of these parameters have to be changed to accommodate the design of the new battery. So it can be done, but it's not as easy as just remove a lead acid battery and then replace it with a lithium ion. So hopefully that answered that question. So the next one is, how many of this type of systems supplied by AMETEK and its size? I'm not quite sure what that question is referring to, Ken. How many of these? Basically, we can supply any size of system up to 225 kVA at this moment in time. All it requires is that the only modification is it has a new control board and a new charge control board. And so all of our DPP range up to 225 kVA can connect to a lithium ion battery. Is that correct, Rob?
That is correct. At the 225 might be, you're not going to have as fast recharge times because we don't offer chargers large enough. Since the 225 kVA charger is the largest we have. So in other applications, in smaller UPSs, we can oversize the charger to really take advantage of the increased recharge current of the lithium ion batteries.
Cool. Okay. Brenda has a very good question. Is the software automatically included with any of the UPSs, or just with UPS systems that are designed for a lithium ion battery?
The communications package that we offer can be used on any UPS that we have, whether it's our PWM UPSs or our ferroresonant UPSs. Just the lithium ion, the new lithium ion measurements and stuff are implemented into the existing software.
Okay. Cool. And I knew this question would come up eventually. Joe, what fire detection, fire protection is incorporated into the lithium ion battery? Now, we are not SAFT reps, so we are not 100% versed in all of the protections that are available. But to answer your question, Joe, the one protection that is the one and only protection on the SAFT Flexion battery for if it detects an over temperature is it will open the disconnect between the charger and the battery to prevent any further current going to the battery affected. So that is the really, it has no active fire detection inside the cabinet, although I think SAFT said that you can get that. Is that correct, Rob?
I believe they have an option for even like a fire suppression system inside the cabinet.
Yes.
But don't quote us on that.
Yeah, that is a battery manufacturer specific question, Joe, which unfortunately we cannot answer. But yes, I'm pretty sure you can ask for a fire suppression system within the lithium ion battery as well. With the customer allowed to set a battery temperature alarm, is there a safeguard that will not let them set it to an unsafe temperature? I don't think they can change the alarm in the SAFT system. Is that correct?
Not in the SAFT system, but we have one on the display board that is separate from the SAFT one. And if you'll bear with me for a second, I'm checking on the range of that alarm right now. Let's go on to the next question.
Okay, but what you're saying, yeah, that's fine. But what you're saying is the UPS will still get the SAFT battery alarm to tell you that it thinks it has a high temperature.
Yes, and I believe that the SAFT set point for that is over 70 degrees C.
Okay.
And I have it here. The R range for the battery temperature alarm is 0 degrees C is the minimum, and the maximum is 50. So okay. Ours is like a first level high temperature warning.
Okay.
So
the next question is, have AMETEK supplied this type of system for offshore application? Ken, we are in the process of doing that. They are in the factory at this moment in time, going through factory acceptance testing. Has that been completed, Rob?
No, it has not, but
it is in process.
Yeah.
Okay, and that is going to an offshore platform that is being floated out to the Gulf of Mexico, I think it is, in 2022, I think. So it has been purchased, but it is not in operation yet. The next question from Terry, can they be recycled? Good question. Rob, do you know anything about the recycling?
I believe that's manufacturer specific, and I think SAFT does have a recycling program.
Okay.
Once again, don't quote me on that.
I'll be brutal and brutally honest with this. Basically, recycling usually is driven by cost and profit. So if the manufacturer can see a benefit in providing a recycling program, they will. And as far as I am aware, obviously there is a shortage of the minerals that are required to create a lithium ion battery. So they are incentivized to create a recycling program. So Terry, as far as I am aware, most of the manufacturers do have a recycling program, and it's specifically so they can get the minerals out of their old batteries and reuse them in their new batteries. Okay, there's a good question. I don't know if we can answer this, but what's the cost ratio between this type of system and a conventional lead acid system? I know that they mentioned it at our meeting, Rob, but I can't remember what it was.
They were non-committal on that.
Okay,
So it's definitely more expensive. Some of the SAF talking points were that, yes, it's more expensive, but the total cost of ownership is less because lithium-ion batteries have much less maintenance required than lead acid, and they are built to last for more cycles and longer amount of time. Like SAF quotes 20-year lifespan of these batteries compared to 10 to 12 for lead acid.
Yeah. Okay. And I've heard 2 to 3 times is usually the multiplier for lithium-ion batteries compared to lead acid, but it is battery manufacturer specific, and we are not a battery manufacturer. We just team up with the battery manufacturers to supply ideal charging applications for their battery. So sorry we couldn't answer that a little bit better. Nathan says, I've read that lithium-ion batteries have nuclear grade dedication. Have any commercial nuclear plants installed them yet? And if so, have they had any success in using them in safety related applications? I know of nobody who, no safety related applications that have installed lithium-ion batteries. I don't know if you do, Rob.
I don't know of any either.
No, and I would suspect that that is not the case at this moment in time. It's probably going to be one of those situations is nobody wants to be the guinea pig, I suppose, in a nuclear safety related application when they know that lead acid batteries can be relied upon and they have the space available to do it. So I don't have conclusive data for you, Nathan, but I would suspect that that lithium ions have not been used that I know of. But I'm sure it will be discussed at BATCon in Florida at the end of this year. So next one is, how many of this types of lithium batteries are supplied by AMETEK to this customer? How many systems are going on the platform, Rob? Do you know?
Four on this platform we have right now. I don't know if Ken is asking how many different lithium battery companies that we can interact with. Right
no,
now,
I think he's just saying how many project,
how many installed. Yeah, okay.
So that's 4.
4. We have, go ahead.
I think we have others in the pipeline as well, but not platform related.
Yeah, how many retrofits did we do for the non-communication based ones?
I only know of 2 so far, but that's only ones that customers have contacted us knowing that there may be issues. Some other customers may have done it without our support.
Yeah, true.
Ooh, goodness me. Mitch has put a question in there. Mitch, in truth, like I said, we are not battery manufacturers. The question is, what percentage of sales in 2020 included lithium batteries, and what do you expect for 2021? We are not sales related. We are not battery manufacturer related, and we can't answer that question. I can pass that on to our sales team and see if they can get an answer for you, Mitch. But it may be difficult. That's more of a question for people like Saft, Enesis, who are all trying to figure out how lithium ion is going to overtake lead acid in their sales going forward. I do see that there is a push for it. There is a genuine want for lithium ion batteries. It seems to be the buzzword just now. So I can see sales increasing, but I have no data to back it up. Next question is, what is the maximum room temperature the system can operate before it shuts down the discharge process? I don't think it does ever shut down the discharge process. Is that correct, Rob?
No, it does stop it if it is above 70 degrees C. It stops discharging and recharging.
Oh, wow. Okay.
At that temperature, you're risking fire. And SAFT and AMETEK's main goal is to safety. Yeah.
Okay. Exactly. So the battery, the disconnect on the battery, the SAF Flexion system will open at 70 degrees C, which is pretty darn hot. Mm-hmm.
And if that, sorry, if it does if the battery does disconnect during a charging cycle, the UPS will automatically transfer the load to the bypass.
Yes.
As long as bypass is available, of course.
Actually, that's a good point to bring up as well. Rob mentioned it in his presentation. There is a contactor and a contactor and a diode. So it can shut down charging of the battery. So if it sees something that's going wrong in the charging of the battery, it can shut down the charging. But with the diode, it will allow the battery still to discharge into the UPS. Am I correct in saying that?
So I think I should have been more clear on this. There are actually you have the contactor on the battery, the diode, and then in front of that, in between the battery and the UPS, is also a circuit breaker.
Yes.
If the circuit breaker is open, you cannot charge or discharge. And the circuit breaker opening is, I believe that's what would happen if you go over 70 degrees C.
Yeah. But there are other circumstances where it says, okay, I think there's something going wrong with the charging.
Like if the charger provides a higher voltage than the battery can handle, it'll open the contactor, but discharging will still be available.
Yeah.
And in all these cases, you will get alarms on both the UPS and on the battery.
Yeah. Okay. Do you know what the biggest UPS that's going offshore is?
I think they are all 4 of them are 20 kVAs.
Okay. And the next question is typical delivery time. We have no increase in delivery time for these systems, I would assume. Rob, is that correct?
I'm not sure about how long what the delivery time for the batteries are, but our UPSs, there's no change in the delivery time.
Okay. Let's have a look. What type of maintenance is required for LFP type batteries? That's a very good question. This is new technology, and what the battery manufacturers are saying is there is no maintenance required for the LFP type batteries. Now, whether IEEE or somebody else gets involved and says that there should be is up for debate, and that will probably be debated at BATCon down in Florida in November. But at this moment in time, that is where the majority of the cost savings come from when you purchase a lithium ion battery, is the manufacturer saying pretty much you put it in and it will take care of itself. So the next question is, why would it transfer to bypass? Shouldn't it just disconnect the battery?
Yeah, Joe, I misspoke there. It will disconnect. It won't transfer to bypass unless the main input is lost.
Okay. So
it'll continue to operate on the inverter until
the rectifier.
Yeah, on the rectifier. Yeah. And the load will be supplied by the inverter until you lose the AC voltage. Yeah.
And the last question that we have is, can you tell us the system you supplied offshore is certified by ABS or DNV? I'm pretty sure that SAFT went through the ABS. They had to get it offshore. I wasn't involved in that process. Do you know anything about that, Rob?
No, I have no idea.
Okay. I know when SAFT were in the Houston office doing a demonstration for us and for the client that these UPSs are going on, they specifically said that they couldn't buy these batteries if they couldn't get ABS or DNV classification. So I know that they had to have done that. I just have no conclusive evidence to say that was the case. But to get offshore, it had to be ABS certified in the Gulf of Mexico. What maintenance is required for the UPS, and what is the frequency? Well, Nathan, it remains as we would usually recommend for our normal UPSs. We recommend that you do annual maintenance, 5-yearly maintenance, and 10-yearly maintenance. And if you need any more information on that, just let us know. So, do we have any more questions? Did you see any I'd missed, Rob?
No.
No? I'll give you a few more minutes if you have any more questions to ask. But once again, please understand that we are a UPS manufacturer. We are not a lithium-ion battery company. In fact, we're not a battery company in the slightest. We leave the experts to that. We create the UPS, and the battery manufacturers design the best batteries to be connected to our UPS. And as far as we know, we are the only UPS manufacturer that has gone out of its way to find a way to communicate with the battery, to take care, to work with a third-party battery manufacturer that allows the fast recharge and allows all of the data from that battery to be sent to the UPS, and then therefore you only have one point of reference for your SCADA system. You don't have to run two SCADA connection cables out to your system. So that's really what we're trying to do here. We're trying to create a system that utilizes the benefits of a lithium-ion battery to give you the best system when you purchase from us. It says, can you provide us a contact to inquire more about this type of system? Taylor, if you can get with Ken, that would be perfect, and give him the details of who he can contact in sales to find out more about our systems. Taylor has put in our chat bar there that this webinar has been recorded, and it will be put on our YouTube website. She's put the link in there to take you there. It won't be live until probably tomorrow or Friday. And you will also get a link to the webinar replay of this webinar. The problem with the webinar version of it is you can't rewind and fast forward. It's treated like a webinar. You have to watch it from start to finish. So it's much better to wait until the YouTube version is put up, and then you can fast forward and rewind as necessary. So,
Craig, we have another question from Mark. What about WECC compliance?
Oh, did I miss that one?
Yeah.
Okay, that's a very good question, because I don't even know what WECC compliance is. Forgive my ignorance. I'm trying to rack my brains. I'm sure a quick Google will bring that up for me. Okay, yeah, I knew it was familiar. That is the it's how we get rid of things, if I remember correctly. Compliance United States. I'm going to have to look into that a little bit more and get back to you on that, Mark, because I am not particularly familiar with it, but I know that if compliance is necessary within North America, then we would have gone out of our way to figure that out. But at this moment in time, I cannot confirm or deny whether we have WECC compliance. But I have taken a note of that question, and we will get back to you. So I think that's worked out pretty good. We're just short of the hour mark. And if you have any further questions, even if you watch the webinar back on the Webinarjam, you can still ask questions as if it's a live webinar. I will get an email saying that somebody has asked a question, and I will reply via the email system if you have questions after we have finished. And also Taylor has given you the contact details if you need to contact us as well. So I would just like to say thank you for taking the time out of your day to join us on this webinar. We do understand that you are very, very busy people, and for you to take an hour out of your day and watch this is truly appreciated. We hope you learned something, and I hope you understand that AMETEK Solid State Controls is trying to stay at the front of all the technology that is available to industrial UPS systems. And that was our main aim today, is to show you that we are at the forefront of lithium-ion technology when it comes to the interaction between a UPS and a battery. So once again, you will get a survey after this webinar. Personally, I'm interested in hearing what you would like us to discuss at the next webinar. So please think about that. If there's something that you really want us to go into at the next webinar, let us know. At the moment, I think it's planned to be how a rectifier works and the ins and outs of how rectification and battery charging works. So look out for the emails on that. But until then, thanks again. Take care of yourselves. Enjoy St. Patrick's Day. And I will speak to you again in a month's time. And thank you very much for taking time out of your day, Rob. It was really, really interesting.
Yep. Thank you.
Okay. Take care, everybody. Thanks and goodbye.